Our lesson on 2.7 part 2 is going to talk about a very particular type of function that is a piecewise function, but we're going to refer to him as a step function. So first, I want to review a little bit about piecewise functions, and let's look at this example. So f of x has 4 parts, 1, 2, 3, and 4, depending on which domain you're on. So if you're between 0 and 1, your function is going to graph at a 1. Between 0 and 2, or 1 and 2, it's going to graph a 2. Between 2 and 3, it's going to graph a 3. And between 3 and 4, it's going to graph a 4. So let's look at what this looks like, because it's kind of strange. So the first function, between 0 and 1, we're going to graph f of x equals 1. Now f of x equals 1 is just a flat constant function at 1. So between 0 and 1 is right here. Oops, excuse me. Now, for the next part, between 1 and 2, he's actually a 2. Oops, hello, excuse me. Now I'm leaving off something kind of important. If you notice the endpoints here, it has a closed circle on the left and an open circle on the right. So technically I should be drawing closed and open circles. A little hard to do on a teeny tiny function. And that's why I'm really not going to do it. So if it's okay with you guys, I'm going to leave off the endpoints. But I just want you to understand that these do have open and closed circles. Closed on the left, open on the right. So between 2 and 3, it's a 3. Oops, that was wrong. Jeez, I'm on a roll today. Between 2 and 3, it's a 3. Goodness. And then between 3 and 4, it's a 4. Now, if I continued this function over the entire domain, it would actually be called, its official name is the greatest integer function. Now we're going to specifically call these step functions today, and they're called step functions because they look like little stair steppers. And this particular one is kind of unique because he would be written as f of x equals, and then his symbol is really kind of strange. It's like 2 brackets, and then this one would look like that. It actually shifted up 1. We'll talk about the shifts a little later. But the step function is written with 2 brackets. And I'm going to show you how to get these on your calculator because I think these are a little hard for our brain to grasp. The greatest integer is also known as the round down function. What it does is it takes any decimal value and always rounds it down to the previous integer. And that's why you see this little flat stair step looking graph. And it hops. So anything between 0 and 1 would round down to a 0 normally. Anything between 1 and 2 would round down to a 2. It's not so important you know how to evaluate these. I just want you to know how to find this on your calculator. So first thing we're going to have to do is open up our calculator. I'm going to have to minimize my screen here. And when you go to your calculator, we're going to graph. So I want you to go to y equals. Alright, let's grab. Okay, let's go to y equals. And then to pull up the greatest integer function, you go to the math menu and you go over to the number category. And the number 5, int, stands for the greatest integer function. That's where you will find him. So if I'm on my presentation back here, and I want to graph number 2, the greatest integer of x minus 2. So we pull up the greatest integer, and then you type x minus 2. Now, because I closed the parentheses after the minus 2, I'm telling my calculator I want the minus 2 to be inside the greatest integer brackets. Go ahead and hit graph. Now, on my calculator, because this is an older model, you're going to notice it connects all my stair steppers. And that's not what I really want to happen. So if this happened to your calculator, what you're going to have to do is go to Mode, and then there's an option that says connected or dot. And you're going to want to switch it to dot mode. So go highlight dot, and now when I hit graph, I'm going to see that they're no longer connected. So I'm going to try to transfer this to my paper as best I can. And the first thing I notice is I try to graph where it is on the x-axis. So this guy, oops, is actually right there. Whoops, whoops, whoops. Now, as you can tell, I'm not doing such a hot job graphing here. It's going to be tough for me to graph this on my tablet. So it's going to kind of step up like this and then step down like this. Oops. And it continues, but I'm going to kind of stop there because it's almost painful for me to do this on the tablet. But the next part of the directions say, can you identify the shifts? Well, normally this guy is highlighted, or it has a first step right here between 0 and 1. And he seems to be shifted to the right 2 units. And that's exactly what happened. Now some people would argue, oh no, I think he was shifted down 2 units. And they're not wrong. They're actually correct. Stair stepper shifts can either be horizontal or vertical, and you can describe them in 2 different ways. So whether you said this was shifted right 2, or maybe some of you thought this was shifted down 2, either answer would be correct. Alright, let's go ahead to example number 3. We're going to do the absolute, oh sorry, not the absolute value, excuse me, the greatest integer of x plus 3. So changing this to x plus, whoops, plus 3. Now, if your calculator still connected them, mine did not, but some of your older calculators, even though it says dot mode, it might still be connected. What you'll have to do is actually toggle between connected and dot one time. If it didn't connect them, then you have a newer calculator, and that's good. So we're going to transfer what we see on our calculator to our paper here. And I'm going to do the best I can, but I'm sure you can tell it's not going to be that good. Alright, so we've got this guy. Oops. Goodness. Now again, this is hard for me, so I'm going to stop there. But it does continue along the whole domain, so if you could please continue it. And if you can figure out how you think this was shifted, well, some people might think it was shifted left 3 units. They would be correct. But some people might argue, oh no, 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 I see that this is shifted up 3 units. They're also correct. So however you see these functions as being shifted, whether it's left 3 or up 3, you're correct. Okay. The next problem, if I go to my calculator, has the greatest integer of x plus 3. So back to my y equals the greatest integer of x. Let's close our parenthesis there. And then the plus 3 needs to go on the outside. So we're going to see a very similar graph to what we just looked at. It does seem to be shifted up 3 to some of you, and some of you might think it was shifted left 3. However you want to think of that, you're correct. So I want you to take this and transfer it to your paper. Now again, I want to caution you, each one of these stair steppers has an open and a closed circle on one end, a closed circle on the left side, and an open circle on the right side. I'm not going to make you graph those because that would just be too much to look at. So just draw me little tiny stair steppers that match what's on your calculator. Okay, we're going to do the same thing for number 5. This time it's the absolute value, greatest integer of x minus 4. Whoops. If you lost it like I just did, remember you go to math, over to number, down to the integer, which is number 5, minus 4. Make sure you do a subtraction, not a negative symbol. Now I have to go and switch my mode because it needs to be toggled. Okay, back to dot, and now I have it correct. So some of you might think this was shifted down 4, some of you might think this was shifted right 4. They're both correct. I want you to transfer what's on your calculator to what's on your paper. Okay, if you need to pause, go ahead, but I'm going to move on to the next problem. Okay, the next problem is the greatest integer of 3 times x. So we're going to have to be a little careful here. Greatest integer. Oops, lost it again. It happens. Of 3x. This time the 3 is multiplied by the x. Now I'm going to have to, when I graph, it's going to be connected again. So I'm going to have to go to mode, and I'm going to have to change it by toggling between connected and dot one time. Alright, there we go. Now my calculator is really not showing this too great. I'm going to switch my window. I'm actually going to go a little smaller. I'm going to go -9 to 9. Let's see if that helps. Oops. It's really not. For some reason my calculator program is not showing me anything too pretty here. So I'm just going to go ahead and try to draw this one by hand, so bear with me. On your calculator, you see the correct answer. And what happens here is when you throw a 3 in front, it takes these little stair steppers and it stretches them by a factor of 3. So, oops, vertically. So this first guy doesn't move because 3 times 0 is still going to be a 0. But that next step, instead of being at 1, he's going to be amplified by a 3, so he's actually going to be up here at 3. And then the next stair stepper, instead of being at 2, he's going to be stretched by a factor of 3, so he's actually at a 6. And then the next one's going to be at a factor of 3 again, so 9. And then they're going to continue on in the next direction. So this guy will be at -3, -6, whoops, and -9. And again, I'm sure yours looks much prettier than mine, but that's what it looks like when you stretch it by a factor of 3. So for number 7, without even touching our calculator, we can kind of think the same thing's going to happen, but this time by a factor of 4. So the 0 is not going to change, but the next stair is going to be at 4, because it's stretched by 4. And then the next stair is going to be at 8, and I ran out of room, so I can't go to 12. So same thing in the negative direction. This is going to be at -4 and then at -8. So the bigger the scale stretch, the less steps you're going to be able to draw for me. Now again, I apologize for the hideousness of my graphs. I need you to make sure you copy exactly what's on your calculator. Just make sure you're not connecting these. These are always stair steps. They're different. Do the best you can on your homework. If you need to use a graphing utility for every question, that's fine, as long as you know how to use it.